Okay, today is analyzing quadratic graphs. So yesterday you should have learned how to graph them. Today we're going to look at graphs and decide how they relate to each other. So are they more narrow? Are they wider? Is it upside down? Things like that. Did it shift? So these are all tips on what to look for. So the first number, the one that's in front of x squared, that's the number called a. So it tells you a couple things. If a is positive, then the parabola opens up. So it looks like this. That's what it means by opens up. If it's negative, if that number is a negative number, then it opens down. So that's one thing that this first number tells you, if it opens up or if it opens down. The second thing it tells you is how wide it is. So the smaller the number, the absolute value, the wider the graph. So that seems kind of weird. So if it's a fraction or a decimal, then it's a pretty wide graph. If it's a bigger number, like 5, which doesn't seem big, but that's a lot bigger than a fraction is. So if it's like 5 or 8, then it's wider, more narrow than a fraction would be. So the smaller the absolute value, so it says absolute value because we're not looking at the negative. So completely ignore the fact if it's negative or positive and just look at the number itself. So the smaller the number, the wider the graph. And then the last thing we're going to look at is this last number. So it's the number without an x on it at all. It's just a number. It's the y-intercept. So what does y-intercept mean? Anybody remember? Where it crosses the y-axis. So it also shows if the graph shifts up or down. So like if this is a positive 5 and a different one is a negative 1, that means it moved down. Okay? So several things to look at. Keep that in front of you while we go over these few graphs. So first we're going to match. That gives us 3 functions and 3 graphs. So you may not be able to see that very well, but we'll try. Can you see all the numbers? Okay. So we're matching A, B, and C, the graph, with whatever function it goes with. So a couple things to look for. First is A positive or negative. So the first number is it positive or negative, because that'll tell you if it's up or down. So do you see any that you could match pretty quick?
1.
3 and what?
B.
B. Because why?
It's different from the other ones.
Okay. How do you know?
It's the only negative.
It's the only negative. So A here is a negative 4. If it's negative, which these other two are not, then that graph has to be going down, facing down. The only one that faces down is B. So 3 has to be B. We good with that? Okay, cross that one off. Now we have to figure out the other two. So do you see a difference in the two equations? Okay, the 5 is exactly the same, right? So that doesn't help because they both go through 5. But this number in front, this one's a 1, this one's a 4. So remember I said the smaller the number, the what? The wider the graph. So the smaller number here is this equation. So what graph would that go with? C. And then that leaves A for number 2. Any questions on how we match that? Okay, let's look at example 2 then. So this one is without graphing. We're going to describe how each one of these graphs would compare to this original one. So on your notes, go ahead and write that down because I'm going to zoom in just a second. So put that we're comparing all of these graphs in just a second to y equals x squared. So just compare to y equals x squared. Okay, so number 1, go ahead and write this equation down. So remember we're comparing that to y equals x squared. So we're just going to describe how it's different. Did it move up or down? Did it get wide or narrow? Did it flip? So that's what we're looking for. So what is different in the equation? Okay, so is the A value exactly the same?
Yep.
When I say A value, what am I talking about?
Number in front of the x.
In front of the x squared, right? They both have a 1. So that's exactly the same. That means the width didn't change at all, and it also didn't flip upside down. So that's exactly the same. The only difference is the C. So the C here is 2. The C here is what? 0. So how could we describe what this graph did compared to that one? Did it go up or down, you think? If the y-intercept originally was at 0 and now it's at 2, it went up. So you could say it shifts up 2. And that's it. Let me draw a sketch really quick just so you kind of know what I'm talking about if you're still a little bit confused. So the original graph I'm going to draw in purple, and then I'll get a pencil and draw the other one. So it goes through 0.
Trenton Staten, please report to Mr. Bradley's office. And Kayla Aguayo, please report to Mr. Bradley's office. Trenton Staten and Kayla Aguayo, please report to Mr. Bradley's office.
Okay, that's this one. Goes through 0. And then pretend that I draw this exactly the same width. It's not going to look the same, but pretend it is. So it goes through 2. So right here. So it stayed the same width, it just moved up. Does that make sense? So that's what it's asking. How did it change? Okay, let's try number 2. So go ahead and write that one down. So again, we're comparing it to y equals x squared. So do you see anything that's different? It's negative. So the a value is -1 in this one, and it's +1 on that one. So if it's negative, it did what? Flips down, right. Is the width the same? Yeah, because the number didn't change, just the negative. Did it shift up or down, or did it just flip? Just flipped. Any questions on 2? Okay, go ahead and write down number 3. Okay, we're comparing it to y equals x squared. So what changed? It's a fourth, so it got what? Wider. How do you know?
Because when it gets smaller, it's wider.
Right. So the smaller the number here, the wider the graph is. So did it move up or down?
No.
Did it flip?
No.
All it did was get wider. So let me draw a picture of that real quick. This one, again, is right through 0. Pretty standard parabola. This one, still through 0, it's just wider. So it's something like that. Okay? Any questions on comparing those? Okay, next example. Oh, actually, these are on your own. You're going to need to know this equation. Write that down first. This is what you're comparing to.